Okay, this is review for the chemical reactions test. So, first thing you need to know are types of reactions. There are 5 types of reactions that we are focusing on. The first one is synthesis, which is forming something from the parts. So it's going to look like A plus B goes to AB. You'll see it only has one product. And it could be A plus B plus C goes to ABC, but you'll only have one product. That's how you'll know it's synthesis. The opposite of that is decomposition, which is AB or ABC breaking down into A and B and C and etc. It doesn't really matter how many parts, but you only have one reactant. Remember, the reactant is on this side and the product is on this side. And it breaks apart into those two or more products. So synthesis and decomposition are opposites. Single replacement, which we'll spend more time on in a little bit, is going to be A plus BC. Now, A is alone. That means it's an element. And it's going to take the place of either B or C, depending on if it's a metal or a non-metal, and you can determine that by table J. Okay? If A is above B on table J, then it can replace it. It can take B's date. B is at the prom with C. A comes along and C will leave B for A because A is higher on table J. Table J is a popularity list. So we end up with A, C, and B left out in the cold. Okay? The next type is double replacement. Double replacement, you have 2 ionic compounds, and they're usually ionic. I didn't mean to do that. There we go. They're always ionic, really. A, B, and C, D. What happens here is that the positive ones stay in the same place, but the negative ones, which are written second, switch. Okay, remember the positive's always written first. That's why we rewrite them when we predict products. And they just switch partners and everybody's happy. The last one that we learned was combustion. Combustion is very specific. You're going to start with a carbon compound, such as CH4. You're going to add oxygen, like O2, and you're going to end up in CO2 and H2O. This part is always the same, okay? So this part of the reaction is always the same. The coefficients might change due to balancing. In this case, it would be 2 and 2. But otherwise, it's going to always stay the same. So if I ask you to write the formula for the combustion of something, you just write it. Don't forget you need oxygen to burn, and the products are always going to be carbon dioxide and water. Balancing and conservation of mass. First thing you need to remember is that there are 3 things conserved in a chemical reaction. In a chemical reaction, 3 things are conserved: charge, energy, and mass. And what we are going to focus on mostly is mass. What that means is the same number of atoms on the reactant side as you have the product side. So on your reactant side, 2 products, you have the same number of each type of atom. Okay, so for example, here's an example of a balancing equation. We'll do a combustion because those are the hardest. Anytime you write me an equation, which you will be doing a lot on this test, you need to make sure that it is balanced, okay? Even if you wrote something wrong, if you balance it properly, you'll get a point, okay? So balancing is really important. First thing to start with, you can really pick anything. I usually leave hydrogen and oxygen for last, so I'm going to balance my carbons. I have 3 carbons here and only 1 carbon here, so I'm going to make it equal on both sides, and I'll put a 3. Then I'm going to look at my hydrogens. Okay, I have 8 hydrogens here and only 2 hydrogens here. So I'm going to put a 4 here because this is multiplication, and 4 times 2 is 8. Now I have 2 oxygens here, and I have 3 times 2, which is 6 oxygens here, and 4 times 1, which is 4 oxygens here. And that's oxygen, not a 0. So I have a total of 10 oxygens on the right side, on my product side, That means I need 10 oxygens on my reactant side. Each one comes as an O2, so instead of writing a 10, I'm going to write a 5. That is a standard balancing type equation. Come on. Where's my eraser? All right. Okay. Last thing we need to know is how to conserve mass, and that'll take place as something like, there we go, that works. That'll take place as something like this. I'll say we have 2 grams of propane, which is this stuff, and 10 grams of oxygen. If we produce 5 grams of CO2, how much water will we produce? And it's just a conservation of mass, okay? So we have 12 grams on the reactant side. That has to equal, because 2 plus 10 is 12, that has to equal 5 plus X on the product side. So X equals 7 grams, all right? That's the easy kind of math that you have to do. Predicting products. You guys have been doing really, really well at this. Here's a quick review for you. First thing you need to remember is that single replacement, you look at table J. You do not look at table F. You only look at table J. Table J predicts if it happens. So here's an example. Zinc plus silver. Let's make it sulfate, because why not? Okay. Remember to put your polyatomic ions in parentheses. Even if I don't put them in parentheses, when you see them, put them in parentheses. Okay. I'm going to underline the 2 things that are in the same column, which is zinc and silver. I want to make sure that zinc is on top of silver. I want to make sure that this one is listed first and this one is listed second. If that's not the case, all I do is write NR, which means no reaction. However, here it is the case that zinc is above silver, so I do have a reaction. What happens here is I'm going to underline the 2 things, see that the reaction happens, and I'm going to switch the places of the 2 things that I underline. Okay, so that's who's going to end up alone is silver. Now, do not be a subscript dragger. Subscript draggers bring the subscript. So here's the subscript 2. I do not want to bring that across with me. The only subscripts I bring are the ones that are inside parentheses, and that's why it's so important to put your polyatomic ions in parentheses. So silver's left alone, and zinc ends up with sulfate. I am going to bring that 4 because it's inside the parentheses. It's part of sulfate, okay? So that's important to bring, but you don't drag the other subscripts. I'm not done yet. I've got to make sure that this is balanced. How I'm going to balance it, I will take a look. I've got 1 zinc, 1 zinc. Zinc is balanced. 2 silvers, 1 silver. So I'll put a 2 in front of the silver. 1 sulfate, 1 sulfate. Now it's balanced. That's all you have to do for single replacement. You don't circle anything because there's no precipitate. You don't use table F. All you use is table J. For double replacement, what you do is you need to first recognize that it's double replacement. You're not going to check table J. So do not look at table J and see if it happens. Just because, there we go, just because you did for the one before doesn't mean we use that again. So for double replacement, what you're going to do is you're going to have 2 ionic compounds. Let's see, what's another good one? I'll use silver, and let's use sulfate again. No. Yeah, let's use sulfate again. Excuse me. All right. So, first step is to rewrite the positive ions. Okay? So, the positive ions are always written first. So, in this case, it's going to be the Na and the Ag. So, I'm going to rewrite them. Na, leave a blank, plus Ag. Again, don't be a subscript dragger. That 2 drops out completely. Okay? Then look up their oxidation states. Sodium is +1. You can find that on the periodic table. Silver is +1. You can find that on the periodic table. Next step is to take the negative ions and switch places. Okay, so the I is going to go with silver, and the SO4 goes with the sodium. Again, because this 4 is in parentheses, it comes over, but the 2 didn't because it's not in parentheses. Look up their oxidation states. Silver's iodine's -1, sulfate. This one's on table E because it's a polyatomic ion. Sulfate is -2. Our next step is to flip-flop. So the 2 goes here, the 1 goes here, and then I usually scribble these out. I don't really care if you do or do not, okay? And then my silver iodide is just 1 and 1, so I'm going to get rid of those, get rid of those. All right. Now you can find your precipitate first, or you can balance first. Let's balance it first. I have 1 sodium and 2 sodium, so I need to put a 2 over here. Just because I gave you this part does not mean you can't write on it, okay? You may need to balance over here, and that's perfectly acceptable. Always show that mass is conserved. So now I have 2 sodiums, and I also have 2 iodines. Since I have 2 iodines, I need to put a 2 here. This gives me 2 silvers and 2 iodines. So now my sodium is balanced and my iodine is balanced. Now let's check my silver. I have 2 silvers here, 2 silvers here. That works. 1 sulfate, 1 sulfate. Now I'm balanced. The last step is to look at table F and circle your precipitate. If you're looking at table F and there's 2 boxes, okay? In this first column, this is table F. First column is soluble, S-O-L, soluble, okay? And then these are the exceptions to that. So this is what you care about. If it's soluble, if it's an exception to being soluble, that's going to be something that you circle. Then the other side is insoluble with its exceptions. So this is what you circle. You don't want this stuff. This is the soluble stuff. So you're looking for the middle 2 columns. In this case, I see that sodium is group 1. So that means it's always soluble. That's going to be like over here. I also see that sulfate is always soluble except with a bunch of things. In this case, sodium is not one of them. So this is not my precipitate. You don't have to cross it off. I just did so that you can see that. Okay? Now let's look at the other one. Iodine is a halide. That means it's like down here on table F if you pull out your table F to look at. Iodine is here, and it's soluble except when it's with silver, lead, or mercury. And in this case, it's with silver. So this is my precipitate. I circle the whole thing. All you need is part of it to be insoluble, which is one of these middle 2 columns, without an exception. Okay? And that's how you know which one you circle. Okay? That's about it. Okay, last thing, you're going to have to write a couple word equations. That's where I'm going to give you the words, and you just have to transcribe it. You don't have to circle anything. The only thing you really need to know for those is you got to make sure you look up your oxidation states. So if it's aluminum chloride, it's not AlCl. It's Al, which is +3, Cl, which is -1. So it becomes AlCl3. Okay. Additionally, you've got to know your Hoberfinkel, Hobrfincl. These elements, when they are alone, are diatomic, okay? So if you have chlorine gas, it's Cl2. If you have iodine gas or iodine solid, it's I2. Notice, okay, that this iodine is not I2, so don't just start adding 2's to all of the Hoberfinkels. It's only when they're alone, okay? And you'll only really encounter that in a word equation on this test. But when they are alone, they are together. They bond to themselves, all right? Otherwise, you should be all set. Good luck.